Good evening, students. Procedure again to discuss a very important point for you. The name of the topic today is paradox in electromagnetism. What is the paradox in physics? There must not be any paradox in physics, but still there is some kind of paradox in electromagnetism we are going to discuss. Ultimately, it will not remain a paradox. Okay, it's a very interesting situation. Just see the situation. This is a disk. This is a disk. Non-conducting disk is mounted on a frictionless support. These are the bearings which can rotate about its axis without any friction. And as you see, these small blocks are shown. They are the non-conducting stubs, positively charged stubs, non-conducting stubs, some kind of blocks rigidly fixed to the disk. They are charged, positively charged. And there is a coil axially placed with a battery and a fuse. Circuit is closed and current is flowing. Yes or no? As you see by this arrow mark, current is flowing. This is the I, current is flowing in the loop. Okay, current is flowing in this loop. Fine. What is the problem? No problem. The whole system is at rest. And these are the lines which are shown, the magnetic fields produced by this current flowing in a coil. They will be forming closed loops, of course. Okay. Initially, the circuit is closed and the steady current is flowing in the coil. The disk is free to rotate, as I told you, about its axis without any friction. Suppose at some point of time, due to some reason, the fuse blows. What do you expect? The current will stop flowing. I'll reduce to zero. So what will happen to the disk? Will it rotate or remain stationary as before? Okay. What will happen? Solution देखते हैं. Now I've shown the fuse blown, current zero, magnetic field has reduced to zero. But we know if the magnetic field reduces to zero or decreases, it creates a non-conservative electric field. That's what we are observing. I have shown the non-conservative electric field as red color closed loops. As the fuse blows, the current becomes zero, the magnetic field decreases to zero, which was earlier non-zero, pointing upward. As you can see, they're pointing upward. Looking from above, we said they're pointing upward. As a result, a closed loop non-conservative electric field appears, as you see the second diagram. And which direction? In anti-clockwise direction as per the Lenz's law, because the field was pointing up, now suddenly reduces in upward direction. So electric field non-conservative should be in anti-clockwise direction looking from above. This you must be knowing. So this field, this is suddenly current B becomes zero. So suddenly this appears also for the a small delta t time. But even then also, it will produce an impulsive force tangential direction on all the charged stubs. So as a result, the closed loop non-conductive electric field appears in the anticlockwise manner looking from above. So the charge stops will experience tangential force in anticlockwise direction because they're positively charged. So this will produce torque about the axis of the disk in anticlockwise manner. Obviously, the forces act like this, torque will produce. So this is basically producing an angular impulse. As a result, this disk will gain some angular velocity. So this rotates due to this angular impulse. Let me write this so that due to this angular impulse, है ना? Right? So now the caveat is raised. What is the caveat raised? भाई देखो, initially the whole system was at rest, right? The electromagnetic field, the coil, the disk, all this constitute this system. Okay, what that electromagnetic field, the coil, the disk, they constitute the system. Okay, the initial angular momentum of the disk is 0. It was at rest, and there is no external interference here. ENC is the electromagnetic is in the electromagnetic field of the system only, not an external force that's created because of the decrease of or the change of electromagnetic field. So B is part of the electromagnetic field system. So this is part of the system, is not external one. The angular momentum must remain conserved. There is no external torque. Therefore, the disk cannot rotate. Obviously, if angular momentum has to remain conserved, then how can disk rotate? If it rotates, this violates the law of conservation of angular momentum. It will get some angular velocity and angular momentum there. I into omega will be there. This will violate the law of conservation of angular momentum, because without external torque, angular momentum is changing. If it does not rotate, the law of electromagnetic induction will be violated. Both laws, if you say it rotates, then the angular momentum conservation law is violated. If you say it does not rotate, then it will violate the law of electromagnetic induction. तो क्या करेंगे अभी आप बताओ भाई क्या होगा क्या? Answer is disk rotates anticlockwise manner looking from above due to the ENC exerting the tangential force on the charge stops at the circumference of the disk. This is the answer. चलो ठीक है भाई. What about the conservation of angular momentum? This law of conservation of angular momentum seems to be violated. No, it does not get violated. The angular momentum remains conserved, because electromagnetic field also stores angular momentum, just like it stores linear momentum. So the total angular momentum will be equal to the angular momentum in the mechanical system plus angular momentum stored in the electromagnetic field. This is a very useful concept. It's a very important concept. The initial mechanical angular momentum Lm bar, call it Lm bar, is 0. But there is some electrical angular momentum in the electromagnetic field. Let it be Le bar. The total angular momentum is the vector sum of these two, Le plus L. So finally, when B becomes 0, the electrical angular momentum of Le reduces to 0. And all of it is transferred as the mechanical angular momentum to the disk. I'll write to the disk. Clear? Okay, so LE initial, and initially there was no LM was 0. So total angular momentum was LE only initial, and total angular momentum final is LM only, because LE is 0, LM was 0 initial. In general, LE bar plus LM bar remains conserved in absence of external torque. Okay, LE bar initial plus LM bar initial. How much? LM bar initial is 0 because no rotation, initial static. So only LE bar initial remain. And finally, what is the angular momentum? LE bar final is 0. So only LM bar final will be there. They will be equal. Angular momentum remains conserved. नोट देखो, angular linear momentum per unit volume, electrical linear momentum per unit volume is given by this epsilon naught E bar cross B bar, and angular momentum given by LE bar is R bar cross PE bar, as you all must be knowing this. R cross P is the angular momentum. So okay, so if either E or B, any of one of them become 0 or both become 0, then PE and LE both become null, 0. But in this situation, initially B and E both were present. B was due to the steady current flowing in the coil, and E due to the charge stops. Both were there. So initially angular momentum was there with respect to a point on the axis from where R is measured. So, but LM was 0, no mechanical angular momentum. But when the B becomes 0, because of current is becoming 0 due to fuse blowing, so then this PE and LE both become 0, but angular momentum has to remain conserved. There is no external torque, so it gets transferred as LM. That's it. So it will rotate. If it rotates, then only both laws are satisfied. Law of electromagnetic induction as well as conservation of angular momentum, both will get satisfied only if the disk rotates. So disk rotates, and this satisfying both the laws. There cannot be any paradox in physics. Finally, that's my statement. क्या भाई समझ में आ गई ये बात? ये बहुत इंटरेस्टिंग प्रॉब्लम है. कोई अगर पूछ लेगा आगे आपको, आप आराम से बता सकते हैं कि भाई यही होगा, क्योंकि एंगुलर मोमेंटम इज आल्सो स्टोर्ड इन इलेक्ट्रोमैग्नेटिक फील्ड, not just as a mechanical I omega or only a mechanical system. Okay, and together both of them, the vector sum of both of these LE bar plus LM bar will remain conserved in absence of external interference or external torque. Or that's it. Is it interesting? So you have understood a new concept. It's not a paradox, it is a law and looking like paradox. Okay, there, as I told you, there cannot be any paradox in physics. Right? All the best to all of you for your upcoming examinations. So this is my credential. Go through my discussions whenever I am putting any discussion for you. Go through that. Every discussion will have some crucial point to note, and every discussion will increase your conceptual clarity. Okay, thank you all. Best of luck to all of you. We'll meet very soon with a new concept. Thank you all.